There are moments in history that change everything. Today, August 19, 2025, we stand at such a threshold. The James Webb Space Telescope has detected signs of life on a distant world, TRAPPIST-1e. This discovery unites us all under the same star-filled sky. The silence has been broken. The universe is more alive than we ever imagined. The James Webb Space Telescope, or JWST, is a marvel of engineering, born from decades of collaboration between NASA, the European Space Agency, and the Canadian Space Agency. Launched on Christmas Day in 2021, its primary mission was to peer back to the dawn of time, to see the first stars and galaxies flicker into existence. Unlike its famous predecessor, the Hubble Space Telescope, which orbits the Earth, Webb travelled to a special point in space nearly 1 million miles away. Webb's primary mirror is a work of art, composed of 18 hexagonal segments made of beryllium and coated in a microscopically thin layer of pure gold. This immense size allows it to gather more light, enabling it to see objects that are much farther away and much fainter than anything Hubble could ever hope to observe. The TRAPPIST-1 system has been a source of fascination for astronomers since its discovery. Located just under 40 light-years away in the constellation of Aquarius, it is relatively close in cosmic terms. The system is centered around an ultra-cool red dwarf star, much smaller and dimmer than our Sun. What makes it so special is that it is orbited by at least 7 rocky Earth-sized planets. TRAPPIST-1e, the 4th planet from its star, quickly became the prime candidate for further study. It is a little smaller than Earth and receives a similar amount of light from its star as Earth does from the Sun. The observation campaign began in early 2025. Over several months, Webb repeatedly observed TRAPPIST-1e as it transited its star. The telescope's near-infrared spectrograph was tasked with the delicate job of dissecting this light. The data that came back contained something far more profound, something that went beyond mere habitability. The atmosphere of TRAPPIST-1e contained a combination of gases, a specific disequilibrium that is incredibly difficult to explain through geology or chemistry alone. The signal from TRAPPIST-1e was a subtle symphony of missing light. Webb's spectrograph revealed water, carbon dioxide, methane, and a large quantity of oxygen, gases that shouldn't coexist unless something is producing them. This is a biosignature, a whisper across the void, hinting that life may thrive far beyond Earth. The James Webb Space Telescope has found compelling evidence of a biosphere on the exoplanet TRAPPIST-1e. A biosphere is the global sum of all ecosystems, the zone of life on a planet. The discovery on TRAPPIST-1e suggests that a similar planet-wide biological engine is at work there. The combination of oxygen and methane in such quantities is the smoking gun. Geochemical processes can produce one or the other, but not both in a stable, abundant mixture. On Earth, that replenishment comes from life. To find this same chemical imbalance on another world is the strongest evidence for life we could hope for without actually going there. The European Space Agency echoed NASA's findings, stating that the most plausible explanation for the atmospheric chemistry on TRAPPIST-1e is the presence of a widespread biosphere. The data is robust, and our analysis shows that the most plausible explanation for the atmospheric chemistry on TRAPPIST-1e is the presence of a widespread biosphere. The search for life has moved from a question of if to a question of what and where else. To truly grasp the significance of this, we need to delve a little deeper into the science of biosignatures. The oxygen-methane disequilibrium is what is known as a Tier 1 biosignature, a sign so strong that it is very difficult to create without life. The scientific community will now race to confirm and expand upon these findings. The first step will be to rule out any false positives, however unlikely they may seem. Future observations with Webb will be crucial. Scientists will want to monitor TRAPPIST-1e over time to see if the atmospheric composition changes. The scientific process is cautious and methodical, but the excitement is palpable. This discovery also redefines our search for life elsewhere. Red dwarf stars are the most common type of star in our galaxy, making up around 75% of the stellar population. The universe might be far more friendly to life than we previously thought. A discovery of this magnitude does not stay confined to the pages of scientific journals. Its impact will ripple outwards, touching every aspect of our society. Politically, it will force a new perspective on global cooperation. Economically, the effects will be profound. The philosophical and cultural impact, however, will be the most significant. Our religions, our belief systems, and our sense of self are all, in some way, shaped by the idea of Earth's uniqueness. The discovery will also accelerate the conversation about our own planet. Seeing a living world from afar will give us a new appreciation for Earth. In our daily lives, this new knowledge will slowly seep into our collective consciousness. It is a gift of perspective, a reminder that despite our differences, we are all inhabitants of one small world in a very large and very much alive universe. To fully appreciate the weight of this moment, it is helpful to hear from the people who have dedicated their lives to this search. Dr. Sarah Seeger, a planetary scientist at MIT, has often spoken about the statistical probability of finding life. The discovery validates decades of theoretical work and technological development. Thomas Zurbuchen, the former Associate Administrator for the Science Mission Directorate at NASA, often spoke of its potential to deliver jaw-dropping discoveries. Of course, the scientific process demands rigor and skepticism. Dr. Abel Mendez, Director of the Planetary Habitability Laboratory, would likely add a note of caution, reminding us what comes next. This is spectacular evidence, perhaps the most compelling we have ever seen. But evidence is not proof. The scientific community must now do its due diligence. If the biological hypothesis withstands this intense scrutiny, then its power will be all the greater. The stars will never look the same again. Today, we stand on a precipice of understanding, looking out at a universe that is fundamentally different from the one we thought we knew yesterday. The discovery of a biosphere on TRAPPIST-1e is a moment that will be etched into the memory of our species. It tells us that the conditions for life are not unique to Earth, that the biological experiment has been run more than once. This discovery is not an endpoint. It is a starting pistol. The next great challenge will be to build telescopes even more powerful than Webb. The journey ahead will be long. The challenges will be immense. We are a species of explorers, driven by an insatiable curiosity to see what lies over the next hill, across the next ocean, and now, beyond the next star. This discovery enriches us all. It gives us a grander story to be a part of. So, what happens next is up to us. We must continue to invest in science and exploration. The journey has just begun.